alaikum. So the lesson today is about quadratic inequalities. So we are going to learn how to solve quadratic inequalities using table of sign. So that's the lesson today. So first let's define what is quadratic inequality. So definition. So quadratic inequality is any inequality defined by ax squared plus bx plus c greater than 0 or less or greater or equal than 0. So we can use any inequality sign for that. So quadratic inequality is any inequality defined by so ax squared plus bx plus c greater than 0. So this is just for example. So we can use greater or equal than 0 or less than 0 or less or equal than 0. So you can use any of this inequality signs. It's still quadratic inequality. So a, b, and c are a number, and a is different than 0. So a, b, and c are a real number, such that we have a must be different than 0. So example, let me give you an example. So 2x squared minus 5x plus 4 is greater or equal than 0, or we can have minus x squared plus 7x plus 2 is less than 0, 4x squared minus 7 greater than 0, or 3x squared minus 7x is less or equal than 0. So those are example of quadratic inequality. So to solve this type of statement, we are going to use the table of sign. There is different method, but I choose the table of sign because that method it's not helpful in this type of inequality. It's helpful even in rational inequality. So that means if you understand how to use that method in this in the quadratic expression, so you can use it even in rational expression. So we're going to use the table of sign. So to solve this type of statement, we are using uh, the following method called table of sign. There are other methods like the discriminant and the leading coefficient. So it's another method which is used especially for quadratic expression. So we'll see this one because this one is a little bit more depth. So we need to talk about how to read the graph. So this is why I prefer to use this because this is more flexible and friendly used by any student. So this is why I choose the table of sign instead of the sign of the discriminant and the sign of the leading coefficient. Alright, so let's see how this one work. So how to use the table of signs, so how to use it. So first thing, so given a quadratic inequality, x squared plus bx plus c. Uh, you can choose any sign. It doesn't matter which sign I choose. So this is just to show you the idea. So first, find the zero that make this expression equal zero, which means solve ax squared plus bx plus c equals zero. Even if you have less than zero or any inequality, first steps you solve for the zero of that expression. That means make this expression equal zero and look for the value that make it equal zero. That means use the quadratic equations concept. So first, when you solve this, you are going to get either uh, two zeros, that means two numbers, or one or none. So we will see those cases later on. So let's assume you got two zeros. Either they are equal or they are different. So let's assume like for example z1 and z2 are the zero of ax squared plus bx plus c. So either they are like z1, let's assume that they are less than or equal z2. Either they are distinct or they are equal. So for both cases, so it works the same way. So then after that, what you do, you draw a table. And the table, it has these two type of table. So, but they are the same concept. So the only difference is the type of inequality you are using. So, the first case. So that case is used for uh, this type of inequality. So when we have this or this, so what you do, you put the z1 and z2 here. Those are the zero that make the expression. This is the real line. That means here is minus infinite. This is infinite. So this is your real line. So those are the zero the expressions. So here is x minus z1. This is x minus z2. So this is, it's like I'm talking about here, this is the value of x. So those are all the x possible. So here at z1, this expression becomes zero. So I'm going to put zero here. At, this is z2. At z2, this expression becomes zero. So I'm going to put zero here. And here what you put the quadratic expression ax squared plus bx plus c. Now, at z1, the whole expression equals 0. At z2, the whole expression equals 0. So this is the idea. Now, what you do, you pick a number here, and you substitute into this expression, and see if it's positive or negative. We don't care about the value you got. No, we're looking about the sign of the value you got, if it's positive or a negative. So if it's positive, you put positive. If it's negative, you put a negative sign here. And the same thing here, you pick another number here, you pick another number here, and check the sign. If you have strictly less or strictly greater, so you're going to use that type of table. So it's the same table, there's no difference between them, the same architecture of the table. The only difference is the zero. So at the zero, what we put here, so when we have z1, z2, this is x minus z1, this is x minus z2. Here we have strictly or less, this is a table for that type. So here we don't put zero here, we put double line. You see, that means we're not including those into the solution. So this is why you put double line. That means here it's mean that it's less than or equal to zero. That means I need to add the zero here where they are equal to zero. That means zero, the value z1 is part of the solution. The value z2 is part of the solution. Here is strictly less or greater. That means they're not going to be equal to zero, which means I exclude those values. So here I have the expression. As you see, is the The same construction, the same thing. The only difference is those two lines that we have here for less than, that means we exclude the value of the 0, which is z1 and z2. That means they are out of the solution, which means here what we use parentheses, and here we use bracket when we express the solution of the quadratic inequality. So this is the table we use. So let's now use example to show you how to use the table with real numbers. So let's do example. So suppose I want to solve for x squared plus 7x uh, plus 5 is less than minus 5, for example. You see the first steps here is you need to simplify, move everything in one side of the inequality. Everything in one side of the inequality. That means simplify expression, combine like terms, keep one side 0 and the rest the whole quadratic expression in one side of the inequality. So first thing what I do here, I'm gonna add 5 both sides. If you have x or x squared on that side, move everything on one side, either the left side or the right side, but keep the whole expression in one side of the inequality, and the other side should have 0. So here it's become x squared plus 7x plus 10 is less than 0. So now what I need to do, I need to make this expression equal 0. So first solve for x squared plus 7x plus 10 equals 0. Here what we do, we factor using one of the method. So whatever you see is available to you, you can use it. So either the direct factoring or the alias method, or here we cannot use AC method because the leading coefficient is equal to 1. So either direct factoring or alias method. So here I will factor directly. So it's going to be x plus 2 times x plus 5 equals 0. Now I'm going to make each one equal 0. So it's going to be x plus 2 equal 0, or x plus 5 equals 0, which means I will have x equal minus 2 or x equal minus 5. Now I have my 2, 0, so I'm going to draw my table. So my real line, this is my x, that means this is all my x, so this is my 2, 0. So here the smallest one is minus 5, and this is minus infinite, and this plus infinite. So here I have the first one is x plus 5, x plus 2, and here I have x squared plus 7x plus 10. So minus 5 make this expression equal 0, so I'm going to put 0 here. Minus 2 make this expression equal 0, so I'm going to make it equal 0. Now I pick a number here. For example, I pick minus 6. Minus x plus 5 is minus 1. It's negative, so that means this will be negative. So keep in mind, so you don't have to pick a number here on the right side. Why? Because on the number line, either we have after the 0 is negative, ahead of 0 is positive. That means when you get one side is negative, the other side must be positive right away. So you don't have to play, you don't have to check a number. Like for example, if I pick minus 3 here, so when I plug in minus 3 here, I get minus 3 plus 5, which is 2, which is positive. So you don't have to check for a number when you got, because this is the 0. This is the same thing in the number line. Look, on the number line, what do we have? We have 0, the left is negative, the right is positive. So this means if you got one side is negative, after the zeros become positive. If you got one side is positive, that means after the zeros become negative. So this is how you should think about it here. All right, so here again, so I pick a number. For example, I pick minus 6 here. So minus 6 plus 2 is minus 4, so it's negative. Here again, still this is the 0. That means if this is negative here, it's going to be negative here. And after 0, it's become positive. Now, to get this, I need to multiply those two. if I need to multiply those two to get the sign, I need to multiply the sign. So, but here this is 0 and this is 0. So minus times minus is positive. This is negative and this is positive. Now what they ask for? They ask for less or equal than 0. Where is less or equal than 0? What does it mean? That means the negative side of that expression. So I'm looking for the negative side of that expression. This is the positive side. This is the positive side. The negative side is located here. So I include those two because they say less or equal than 0. That means they can be 0. So my solution here will be the interval minus 5, 2. Because this is where that expression is less than 0, which means negative. Here is positive. I cannot take it here. And here is positive. I cannot take it here. So let's do another example. So suppose I want to solve for that type of x squared plus 3x plus 5, and this will be less than 0. So first I need to make this expression equal 0. So there is nothing here, so to make it simple, so what I do here, I just make first this expression equal 0 and solve for the 0 of that expression. So I'm going to look for the discriminant. So discriminant is 3 squared minus 4 times 1 times 5, which is 9, minus 20, which is minus 11, less than 0. So when the discriminant is negative, that means there is no solution. All right. So there is no 0 for that expression. That means on the table, if I have no 0, I have the table that has only the quadratic expression. It doesn't have nothing beside the quadratic expression. So this is my quadratic expression, x squared plus 3x plus 5. You see those row, you do them only if you have the 0. If you don't have the 0, that means you have only one row, which is the quadratic expression row. So here, this is my x, it's minus infinite, this is infinite, there is no 0 here. So I don't need to have this. Now, in order for me to check the solution of this, you see they want this one to be 0. What I did, I pick any number between minus infinity and infinite, any number. And the easiest number to pick is what? Is 0. So I pick x equal 0. And I substitute my 0 here. So what I will get? I will get 0 squared plus 3 times 0 plus 5. This should be equal to what? 0 plus 5, which is 5. All right. Is it 5 less than 0? You see, we know that 5 is greater than 0. Is it less than 0? No. So what I do, 5 less than 0. And this is false statement. So which means any number I pick here, it will give me a false statement. Any number. Why? Because this is greater than 0, which means that this one never can be negative, it's always positive. So which means I pick any number, it always gives me a false statement, which means that this has no solution. If it was greater than 0, then I will have all number as solution. Why? Because this is always positive. So this is the case. So if I have, let me do the special case here. So let me draw a line, at least you don't get confused with this. So if we had, for example, x squared plus 3x plus 5 is greater than 0, so that means this statement, so this table, if I do the table again, so I have x squared plus 3x plus 5. This is my x minus infinite, infinite. So it's going to be always positive, and this is always positive. So this is true statement. You see, this is true statement. So what does it mean? Does mean all number are solution. All real number are solution. So my solution will be the interval of a number which is minus infinite to infinite. You see? So this is the difference. You see, we have less than, but this is positive, so it cannot be negative, so I have no solution. But if I have this statement, but the sign is greater than, or even if you have this, it will work. because this is always positive. So we always have or remember for that type of statement. So let me do another example. Suppose I want to solve for x squared minus 3x plus 3 greater than 4x minus 7, for example. Like I say here, first we need to simplify the expression. So what we do here, I will minus 4x plus 7 both sides. So I got x squared minus 7x plus 10 is greater than 0. Now I'm going to solve for this. So it's going to be x squared minus 7x plus 10 equal to 0, which means if I factor, I can take the discriminant, which is minus 7 squared minus 4 times 1 times 10, 49 minus 40, which is 9. So this is perfect square, which means I can factor this directly. So it's going to be x minus 2 times x minus 5 equal to 0. So we end up having x equal 2 or x equal 5. Now, so what I need to do, I need to do my table. So I got my 0. So I got x minus 2, x minus 5. This is 2, this is 5. Here I have double line because this is not equal. So this is 2, this is 5, this is infinite, this is minus infinite. Now, like I said, I pick a number. So if I pick 0 here, it's going to be 0 minus 2, which is minus 2. It's negative. So on the other side, it's going to be positive. And here, if I pick again 0, it's going to be negative, negative, and the other side, it becomes positive. Now, what is my expression? Is x squared minus 7x plus 10. This can be found by taking the product of those two expression. So which means I need to multiply the sign to get the sign of that expression. So minus times minus is positive, negative, positive. Here they ask me for the positive side, so those are the positive side. So my solution will be minus infinite 2. You see, because this is double line, I will not include the 2, so I will do parentheses. And here I have 5 to infinite. So these are my two intervals where this expression is positive. So my solution will be minus infinite 2, and we use that notation, which is union. That means combine those two intervals. So this is my solution for that expression. If you do the number line, you can do the number line this way. So what you do, you put 2 and you put 5 and you put open circle here. So this is my infinite. This is infinite, and you shade the part where it's positive. If only use the number line. So let's do another example. So I'll try to uh, give you as much as I can. In that case, you see all type of inequality you may meet with. So for example, you want to solve for 2x squared minus 4x plus 2 is less or equal than 0. So first thing I need to solve for 2x squared minus 4x plus 2x. So first thing, 2x squared minus 4x plus 2 equal 0. I see that there is a common factor here. So what I do, I divide by 2 both sides because this is my common factor, which is I will get x squared minus 2x plus 1 equals 0. So my discriminant here is minus 2 squared minus 4 times 1 times 1, so which is 4 minus 4 equals 0, which means that this is a perfect square. So x squared minus 2x plus 1 equals 0. This means that x minus 1 squared equals 0. So which means that x minus 1 equals 0 and x will be equal to 1. So in the table of sign, it's not because I have only one zero, I'm going to put only one row. No, I'm still putting two rows. So it's going to be x minus 1, x minus 1. So here I will put only one line for the 0 because I have only one 0 is 1. And this is less than, that means it can be 0 here and it's 0 here. If it's strictly less, I will put 2 bar here and 2 bar here. And same thing on down. Here is my expression, which is 2x squared minus 4x plus 2. So here on the left side, this is minus infinite, this is infinite, this is my x. So here it's going to be negative, this is positive, negative, this is positive. So here it can be 0 here. So minus times minus is positive, and positive is positive. Alright, so here I have a problem. Here they want to be less or equal than 0. And here it shows that this is always positive. So I have this inequality but has less or equal than 0, which means it can be negative or equal than 0. Negative or equal than 0. Negative or equal than 0. The statement is not negative, but it can be 0. You see the choice here? It's not negative, can never be negative because it's positive everywhere. It's positive on that side, it's positive on that side. That means the whole thing is positive. But it can be 0. That means here it's mean less than 0 or equal to 0. That means I have the choice here. It can be less or equal. The statement cannot be less. That means it may be equal. So do we have a place where it's equal to 0? Yes, at 1. That means in that case we have only one solution, is where the expression is equal to 0. If in case if you have that type of the same, for example, and we have 2x squared minus 4x plus 2 and we have strictly less than 0, of course that means I will have 2 bar here and this can never be negative. So my solution here is empty. That means no solution. So for that case, it's no solution because this can never be negative. So I hope you got the idea, and I hope I clear all the question you may have. And please, if you have any comment about the way I teach, which can help me improve my way of teaching, please do so. And thank you for watching the video, and Assalamu alaikum.